Okay, last day of new stuff for Unit 8, and this is just a 2-problem day, so it should go by pretty quickly. The only thing that we didn't cover in the last couple of videos is what happens when you have a word problem. What we hope for in a word problem is that there's a picture already drawn. Occasionally you have to draw your own, so we're going to look at a couple of practice ones where you're going to generate your own picture and then use some trigonometry to solve the problem. So let's just jump right in. This is the next slide of your PowerPoint, picking up right where we left off yesterday. And this is the last slide, nothing after it, last slide of this section. We do have one that we have to go back and get from a couple of days ago, but that one will go quickly. So we have a plane flying at an altitude, that's a fancy word for height, of 10,000 feet, and he's 30 miles away from the airport runway. Okay, so I immediately see an issue. I have feet and I have miles. And I'm going to have to change one to the other before I can do anything useful with this problem. So I'm either going to have to change 10,000 to feet or to miles, or I'm going to have to change 30 miles to feet. Well, feet are smaller than miles. And typically it's easier, it's less messy if you change the larger unit to the smaller unit of measure. So I'm probably going to just right off the bat here change this to feet. So if there's 5,280 feet in a mile, which is something that was on our conversions chart back in chapter 7, hopefully you still have that unit 7 conversion paper, we learned that 1 mile is 5,280 feet. 5,280 feet in 1 mile. So if you're going to go 30 miles, you've got to go 30 of those. So times 30. So that's 158,400 feet. So I'm going to replace 30 miles with 158,400 feet right off the bat so that I have feet, and I'm using the same units. Now I don't have to worry about it anymore. So let's go from there. What angle of depression does the plane need to have to descend to the ground in time to reach the end of the runway? Okay, I need a picture before I can do anything else. So I have an airplane up here. So A is for airplane. I would draw you a picture of an airplane, except that I'm a really terrible artist and you guys already know that. So we're just going to pretend there's an airplane at that point in the sky, and straight down below the airplane is the ground. So down here is the ground. G is for ground. And the altitude is how far above the ground the airplane is. So the length of this side is 10,000 feet. And then we have the ground that we know it's humpy and bumpy and has hills and valleys and other interesting things going on, but this is geometry world where we just ignore those humps and bumps. And way over here is the airport runway. So R is for runway. There's point R of the runway. And the airplane, from the airplane to the runway, the distance from the airport straight to the runway, which is what I'm reading here, the airplane is that far away from the runway. Airplane to the runway is 158,400 feet. Yeah, that's a big number. But we have a calculator, so we're not going to worry about the fact that there's a really big number there. Okay, we're going to assume that there's a right angle that measures the altitude of the triangle. What do we want to know? We want to know the angle, what angle of depression. I'm going to solve for a missing angle, just like I did yesterday. What angle of depression does the plane need to have to descend to the ground in time to reach the end of the runway? So which angle is it? Is it this angle or is it this angle? And this is a classic error that students often make. Most students want to put the angle of depression up here on the top of the triangle. That's the wrong place. It's actually down here in the bottom. So the unknown angle we're looking for is x degrees between the ground and the hypotenuse. And that seems kind of weird, but I'm going to give you some insight into why that's where it is. Okay, I'm going to draw some extra lines in this time, and then we'll hopefully not deal with it anymore. So if you're the pilot, everything is done with respect to the pilot. The pilot is sitting in the plane up here, and the pilot looks out his window at the horizon. Okay, and then the pilot has to drop his line of vision X degrees to actually see the line of sight to the airport. Now technically, it's 30 miles away. He can't really see the airport yet, or maybe he can. I don't know. I don't fly planes. But there is some change between his horizontal line of sight and the actual line of sight down to the runway, and that is the angle of depression. So he depresses or lowers his eyes to see the line of sight to the runway. So that's where the X degrees is, but it's outside the triangle, and that's where the tricky part is. The angle of depression is outside the triangle. But I learned back in Unit 3 of geometry that this angle and this angle down here, those are alternate interior angles along parallel lines. This horizontal line of sight, the dotted line up here at the top, and the ground, those are horizontal lines. The line of sight from the airplane to the runway is a transversal, and these are alternate interior angles, and they have to be equal. So that means the angle I'm looking for is actually in the bottom of the triangle. Here's a really good hint about angles of depression. Angle of depression hint, make a note. It's always between the horizontal side, the horizontal leg, and the hypotenuses, or the hypotenuse. There's only one of them. Okay, horizontal starts with an H, hypotenuse starts with an H. I always say look between the H's. So horizontal side is the ground, hypotenuse is the line of sight down to the runway, and the angle that's formed by those two, the horizontal and the hypotenuse, that's always your angle of depression. So angles of depression are typically at the bottom of the triangle because we normally put our horizontal side on the bottom. But the trick is look between the H's. Between the H's, the horizontal and the hypotenuse. And then you'll get it in the right place every single time. So the only thing that's actually challenging here is to get the picture correctly drawn and labeled. And once you get the picture correctly drawn and labeled, it's really easy to set up the equation. So here's the picture. Okay? We need to label the sides that we know the lengths of. The angle that we're trying to find is down here in the bottom next to the runway. That's our angle of depression inside the triangle. If I look across the triangle from that, the altitude of the plane is the opposite leg. And then the 158,400 foot distance to the runway is the hypotenuse. It's opposite the right angle. Opposite and hypotenuse, if I do so, toa, go with sine. I need a sine function to solve this one. Okay, so sine of the angle, that's what we're looking for, that's x, equals opposite, that's 10,000, over hypotenuse, that's the 158,400. And then to solve it, we'll need to make the sine go away, which means we need an inverse operation. And the inverse operation is the inverse sine. So we'll take the inverse sine of the left side and the inverse sine of the right side. On the left side, things get pretty real quickly. Inverse sine and sine will undo each other, leave the x. On the right side, we have some calculator work to do. Now, if you're really clever, you might cancel those two trailing zeros in the top and the bottom and have less things to type in the calculator. But just in case you don't do that, we'll just type it in whole. So we need to go to our functions, or the trig key if you're on your handheld. We need inverse sine, and we had, all right, let's look at our numbers again. 10,000, need some numbers, go back to the main menu, 10,000 divided by, and it makes it really nice and pretty, 1,58400. And my calculator says that's about 3.6 degrees. About 3.6 degrees. Alright, so x is approximately 3.6 degrees. Okay, and that sounds like a really, really small angle, but when you're actually descending in the airplane, it feels a little bit bigger than that. You can't go down at too sharp an angle at a time without making your passengers really, really sick. Okay, so that's the first one. We got one more to take a look at. So we'll have to go back about, I don't know, it's probably 4 or 5 slides back. We skipped over a problem about a ladder. So go back and find that. If you're having trouble finding it, just hit pause until you do. This one's much easier to draw, much easier to set up, and then it's going to solve super quickly. So we have a 12-foot long ladder leaning against a wall. It makes a 77-degree angle with the ground. How high does the ladder reach on the wall? Round to the nearest inch. Okay, so we have a wall. There's a wall. We have the ground. There's the ground, and you know, this is geometry world where things are pretty. So we're going to assume they are perpendicular to each other. We have a nice right angle there, and then we have a ladder that's leaning against the wall, sitting on the ground. The ladder is 12 feet long, so the ladder is this diagonal side. It's the hypotenuse, so that's 12, and it's a hypotenuse. And it says the ladder makes a 77-degree angle with the ground. So the ladder's here, the ground is here, the angle formed by those two sides is at the bottom. So 77 degrees on the bottom. This is called, we're going to throw in a bonus here, this is called an angle of elevation. How elevated the ladder is. And the angle of elevation is in the bottom of the triangle looking up. So how much did we lean the ladder? We had to lean the ladder to a 77-degree angle so that it doesn't fall down or slide down the wall. Notice that the angle of elevation is in the bottom of the triangle just like the angle of depression was. So it's still between the H's. It's between the horizontal side and the hypotenuse, always. So angle of elevation, angle of depression, both are in the bottom corner of the triangle almost exclusively. We want to know how high does the ladder reach on the wall. So how high up this wall can we rescue someone from the window or just get up there to clean something? So we want to know X, that distance. We're back in a side solving world. So now we have to do a little bit of a review. We did this a couple of days ago. So first we set it up, and before we actually pick a trig ratio, we've got to figure out what kind of side X is. The angle is 77 degrees. X is opposite that angle. Opposite and hypotenuse go with sine. So I need a sine equation. The angle is 77 degrees. Opposite over hypotenuse will be X over 12. So before you start fooling around with an inverse operation here, you don't need an inverse operation for sine. We're not trying to get rid of sine. Sine and 77 degrees are going to be used together. We're going to actually calculate the sine of 77 degrees. The x is on the other side. So when the x is on the right side of the equation in the ratio, that's when we want to put sine of 77 over 1 and cross multiply. Treat it like a proportion. So if we cross multiply, sine 77 times 12, I like to put the 12 in front, 12 times sine of 77 degrees. And in the other direction, 1 times x is x. And x is by itself. The only thing left is to find the actual 12 times sine of 77 in decimal form. So that's going to require a calculator. We'll pick up our handheld this time since it's handy, and do 12 times trig button sine 77, and that's equal to about 11.69, 11.7. Now, it says here to round to the nearest inch. Well, that's a whole number of inches. 7 is bigger than 5, so that means we're going to round this up to about 12 inches. Okay, whoa. I'm thinking that doesn't make any sense now, does it? This was in feet. I'm thinking this was supposed to be feet. Miss Rice had a typo. No question about it. I think this is supposed to be 12 feet. Good thing we caught that, because there's a really big difference between 12 inches and 12 feet. Okay, so that's it for the word problems. You're going to finish up the last practice page before the review. It's page 18 of your packet. You'll have a homework check quiz on Schoology like usual. And then tomorrow we will start reviewing for the Unit 8 test. Spend a couple of days reviewing because there's a lot of information in this chapter. Some of it we haven't seen for about 4 weeks, or probably 3.5 weeks. So we'll need to go back and recover some Pythagorean theorem information and some special right triangles practice that we've not done for a while. So be expecting a test by next Monday on Schoology. Alright, so hang in there, try to get caught up, and tomorrow we will start our review. Have a good day.